This lesson is on rational versus irrational numbers. We're going to first practice just making sure we can identify an irrational number and a rational number. Essentially, the idea is that a rational number can be written as two integers, which are your positive and negative whole numbers, over each other. I tell my students often it's very easy just to go ahead and memorize the three types of an irrational number. So the three types would be pi in any form, the non-terminating, non-repeating decimal. That means that you'll see it with an ellipse. It goes on forever. And then you would also have something that would be like a non-perfect square, non-perfect cube root, something like that. So like the square root of 2 or the cube root of 2 or the fourth root of 2. If you put that in a calculator, they would be ugly. So all of these examples are irrational numbers. So we're going to check them out. For example, can I take the square root of 37? No way, that would be ugly. That's an irrational number. Okay, can I take the cube root of 36? Some number times itself would give me 36. Well, no. If we did the prime factorization of 36, look what happens. We have 36 would be 9 times 4, which would be 3 times 3. 4 would be 2 times 2. Do you see a set of 3 numbers here? Nope, so that is irrational. Square root of 25. I know that that is equal to 5. That has to be rational. 3/7. Is that pi? No. Is it a decimal that is a non-terminating, non-repeating decimal? No. Is it one of these that is a square root cube root of something that's not perfect? No. If my answer is no to all 3 of these, we say that's rational. All right, let's do this one. I have 3 to the negative 5th power, which really should be written as 1 over 3 to the positive 5th power. That doesn't even matter. Regardless of which form it is, let's ask some questions. Is that pi? No. Is that a non-terminating, non-repeating decimal? It looks just like this? No. Is it a square root, cube root, fourth root, anything like that? Something that's not perfect? No. I just said no 3 times. That means it has to be rational. Here I see a pi. That's an automatic irrational. All right, let's go through our questions here. Is that pi? No. Is that a non-terminating, non-repeating decimal? You see the dots afterward? No. Is that a cube root of a non-square root, non-perfect number? No. So 3 no's gives me a rational. Now this one, if you look, is a number that goes on forever, that does not repeat. It falls in this category of non-terminating, non-repeating. So this right here would be irrational. However, look at this one. This one's a trick question. See how this decimal ends? It has no dot afterwards? It means it stops. It does not fall in this category. It is not this type of non-terminating, non-repeating number. So if I ask that question, it would be no, 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 which means automatically this is a rational number. So now with that, we did an exploration in class, and I'm going to zoom in just a little bit here. And in our explanation of our class, we were looking at numbers or statements of whether they were always true, sometimes true, never true. And I'm just going to go through like 1 or 2 of these. It says that the sum of a rational number and a irrational number is rational. So that'd be like 5 plus 1/7, or negative 3 plus 3, so on and so forth. Yes, that is always going to be true, because no matter what, your rational numbers added together would always be rational. Now, if you come up with something like this, and it says that the sum of a rational number and an irrational number is irrational. So let's take 5, and we add that to something like square root of 3. Well, what is the result when we add them together? It's going to be irrational. Can you think of anything, any number that you could add to this where you have one of each type of number that would result in something that's not irrational? No. It's always going to be irrational. Now look at this one here. It says the sum of 2 irrational numbers is essentially going to always be irrational. So that'd be like saying we have the square root of 5 plus the square root of 7. Well, yeah, if we added those 2 irrational numbers together, it's still going to result in an irrational number. There is one little trick to this particular question. There is actually one way we can produce a rational number. Watch. What if the 2 numbers we were adding together were square root of 5 plus a negative square root of 5? What is the result? The result is 0. And 0 is a rational number. So this phrase right here is sometimes true. So now you want to do the same thing with your products of those three sets of numbers and see what you come up with. Refer to your notes and ask your teacher and classmates questions if you still need to go through those and review them.